In this video, we are going to find roots of complex numbers with use of the Moivre's theorem. Now it tells us that if we want to find the root of a complex number, what we shall do, we shall say that it is r 1 out of n cos open brackets theta plus 2 pi k out of n, then plus I sine theta plus 2 pi k out of n, then k can run from 0, 1, 2, 3 up to n. Is that okay? For example, if they tell us find the cube root of 1 plus I, is that okay? If they tell us to find the cube root of 1 plus I, we are going to use the Moivre's theorem to find the required solution. But before we find the solution, we have to say let z be equal to what is in what, in a bracket, such that it's going to be 1 plus I. So we have to find its argument and we have to find its modulus. So it is having 1 on the real axis and 1 on the imaginary axis. So we shall put our points and we shall join them. We shall have a theta. Since it is from the positive x-axis, so it should be our argument, and our argument, we say that it is tan inverse of 1 out of 1. Therefore our theta is equal to 45 in degrees, so theta is going to be 45 out of 180 and a pi. So theta will be equal to pi out of a 4, and r is equal to a square root of 1 squared plus 1 squared. So r is equal to root of 2, and they are what? They are units. Now we need to find the cube root. The cube root of I plus 1. And from the Moivre theorem, we say that z 1 out of n will be equal to r 1 out of n cos of theta plus 2 pi k out of n plus I sine 2 theta plus 2 pi k out of n. So this is guys in the bracket. Then for k is equal to 0, 1 up to n. Is that okay? Now our n, for this case, our n is equal to 3, so we pick this. So our n is what? Is a 3. So we shall say z of 1 out of 3 is equal to our r, it is root 2, so it shall be root 2 power third. Then we have cos, our theta is pi out of 4 plus 2 pi k out of a 3, then plus I sine of pi out of 4 plus 2 pi k out of a 3. So we have to define k. K will be equal to 0, 1, 2 up to n. Now k is going to determine the number of what? K is going to determine the number of roots. Are we together? So now when k is 0, we shall find the first root, and when k is 1, we shall find the second root, and when k is equal to 2, we shall find the third root. We shall start with, for k chosen to be 0, so we shall have z 1 out of 3 to be equal to root 2 power third, then cos of pi out of 4 plus 2 pi, we say that k is a 0 out of 3 plus I sine pi over 4 plus 2 pi of 0 divided by 3. Is that okay? So now we shall have z over third, which is equal to what is root 2 power third? Root 2 power third, it is 1.122, open brackets. Here we have cos of pi out of 12 plus I sine pi out of 12. So z over half third, our z1 will be equal to 1.112. What is cos pi out of 12? It is 0.966. Then plus, what is sine pi out of 12? It is 0.259 I. Are we together? Now we need to simplify to the minimum, so that one will be 1.112 times 0.966. The answer will be 1.074, then plus 1.112 times 0.259. So the answer will be 0.288 I. So that is the first cube root of the complex number. Also we need the second cube root of the number, and at that point k will be a 1, and we shall have 1.112, open brackets, cos of pi out of 4 plus 2 pi, we say that our k is what? A 1 out of a 3 plus I sine pi out of 4 plus 2 pi 1 out of, oh, it's fine, this one is out of a 3. So this one will give us 1.112, open brackets. We simplify that. So it will be cos of 3 pi out of 4 plus I sine of 3 pi out of 4. So what is cos of 3 pi out of 4? What is cos of 3 pi out of 4? So it is 1.12, and it is negative 0.707. Then plus 0.707 I. Is that okay? So if we simplify, if we try to simplify, we shall have the result as negative 0.786, then plus 0.786 I. Now for k is equal to 2, we shall have z 1 out of 3 of 3 to be equal to 1.112, then cos of pi out of 4 plus 2 pi of 2 out of a 3, then plus I sine of pi out of 4 plus 2 pi